right, greetings YouTube, beautiful mind here. Let's see. So this will serve as our lecture for applied statistics for week 4 on Friday. Exam 2 is available. It is up on Pearson. It's been up since about Tuesday. It is due Saturday at 11:59 p.m. I think for you all, I granted you all an extension on some of the homework. I do realize that I posted, because I think the previous week I didn't realize that I hadn't posted it, so I went on and posted the previous week plus this week. So you did have double homework, so I was like, okay, well, I went on and granted an extension on the homework portion, but the exam still holds because that's from a couple of weeks ago, as far as content is concerned. So we do have exam 2 that is still due this Saturday by 11:59, but I went on the assignments. I went on to push the assignments back by a week, just gave everyone in this course a week extension. Also, be sure to complete the what is it called? Participation and honesty quiz that is on Moodle. Okay, I don't know that we can submit a grade without you completing that document, that quiz. All right, I can't think of anything else, so we'll just take some time to kind of go through this section. It's fairly short. I just wanted to talk about this one section, and we'll keep it going. So we want to go ahead and close out chapter 4, discrete probability, with more discrete probability distributions of section 4.3. So some objectives for this section are how to find probabilities using the geometric distribution and how to find probabilities using the Poisson distribution. So a geometric distribution is a discrete probability distribution. It satisfies the following conditions. A trial is repeated until a success occurs. The repeated trials are independent of each other. The probability of success P is constant for each trial. The random variable X represents the number of the trial in which the first success occurs. So we want, when is what's the probability that the first success occurs on the 5th trial or whatever? That's usually indicative of geometric distribution. The probability that the first success will occur on trial X is given by so for instance, say we wanted the probability that the first success occurs on the 7th trial. That means the first 6 trials are going to be failures, and then the 7th is going to be a success. So if X were 7, then that means we would have 6 failures and then 1 success. All right. So that's pretty much how we would solve the geometric distribution. Let's see this example. I just don't want to see the answer. Okay. Okay. So for this example, let me do like this really quickly. Let me add a page. Oh, we might not need that page. It says a study found that the smartphones made by a certain manufacturer had a failure rate of 43%. 4 smartphones made by this manufacturer are selected at random. Find the probability that the 4th smartphone is the first one to have a failure. Okay. All right. Let me think about it. So if we select 4 smartphones, the 4th one to be the failure. So we want the probability that X is equal to 4. What's the probability of success? Let me see. The failure rate is 43%. So 43%. But then the first 3, if failure is 43%, I know we're kind of like doing it in reverse because the target here is we want the first failure to be on the 4th one. So that means the first 3 need to be successful and then the 4th one needs to be a failure. So if 43% is the probability of failure, then the probability of success would be what, 57%? And that needs to occur 3 times before this one. That's about all that I can see there. I'm going to use my trusty dusty rusty calculator. Give me a moment just to get it set up. here. Okay, it looks good. All right. Okay. So for the calculator, let's just do this really quickly. Let's see, 0.43 times 0.57 to the power of 3. And we get approximately, let's do, I mean, it's about 8%. Let's do 0.07. What is 296? It's about 8%. So it's a low probability. Let's see, how do we do? Oh, didn't need that paper. All right. Okay, so using the 43% as a success, and then the failure. I know it's 43. It's a little bit backwards. Like, it's because with the focus, we want the first failure to be on the 4th attempt. That means the first 3 need to be successes. So that means our P in this case is 43%. And then the Q is 57, and then X is 4. All right. So then about 8%. So we can actually do this in the TI-84. We got the geometric probability distribution function. Success is going to be 43%, and we want that to occur on the 4th try. Let's see if we can do that really quickly. I'll just put it here. Should be there. So if we go to distributions over here, and then we want geometric, there it is, D. So this one. 43% on the 4th go, and you see the answer there. Give me just a moment. And we're back. All right. So we saw that we can do it in a Texas Instrument graphing calculator. Okay, so we're going to let that be. So for the Poisson distribution, is it Poisson or Poisson? Probably Poisson. I've never taken French, so I don't know. I'm not sure if it's Poisson or Poisson. Turn this down some. All right. So I'm going to say Poisson for now. So this distribution is a discrete probability distribution. It satisfies the following conditions. The experiment consists of counting the number of times an event X occurs in a given interval. The interval can be an interval of time, area, or volume. The probability of an occurring is the same for each interval, and the number of occurrences in one interval is independent of the number of occurrences in another interval. Okay, let's see if we can see this in action. So the probability of exactly X occurrences in an interval is going to be given by this. We have mu to the power of X times e to the negative mu divided by X factorial, where e is just a the function in the calculator, 2.71818, and mu is the average number of occurrences. Okay. So let's see this one in action. Oh, I didn't want to see the solution. Well, it says the average number of accidents per month at a certain intersection is 3. What's the probability that any given month 4 accidents will occur? So we have our mu is 3, and x is going to be 4. So then mu is 3, x is 4. Then we just basically plug it into the formula. Again, this is just a function in the calculator, this e. So it's going to be 3 to the 4, e to the negative 3 over 4 factorial, and it gives us this. Also, you can do the Poisson probability distribution function in your calculator, where 3 was the average, and we want x to be 4, and it'll give it to us. Okay. All right, let's try that. Let's see what's next. Oh, so finding a Poisson probability using a table. So population count shows that the average number of rabbits per acre living in a field is 3.6. Use a table to find the probability that 7 rabbits are found on the acre field. Okay, so the average is, so the mu is 3.6, and we want the probability that 7 rabbits. So our mu is 3.6. So there's an appendix in the back of our book. So we want x to be 7, and our average was 3.6. So then they intersect here at 0.0425%. Or 4.25%. Okay, so you see our x here, our mu here, and that's essentially it. Okay. You can also do these in Excel and numbers if you're on a Mac. Okay, we can check the table with technology. So yeah, just fairly light. It's a Friday, and you also have an exam available. I'm available if you have questions, so you can ask me questions. I do make dedicated YouTube videos answering questions that students have. If there are no questions, then I just go on about my way. I can't think of anything else other than, I think I went on granted you all an extension on the homework assignments. Why does that look like that? Uh-oh, has it been like that the whole time? Okay. Yeah, so exam 2 is there, and be sure to do the participation and honesty quiz that is on Moodle. If you've done it already, you can ignore that, but just be sure to get that submitted. On that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.